that has leaps and bounds. That's a leaps and bounds. Ganga ma'am, are you recording the session? Because
Yes,
I'm
ma'am.
not getting the option. Okay, thank you. So here it is. Big data as the session goes is actually the flow towards how data, its nitty-gritties went towards the information, and then information towards a leap on a huge parameters of applications, and of course the classification, the clustering and regression goes with it. So big data makes that parameters visible for us and approachable as well. So big data analytics, we will be having the latest trends on the definition on the part of the various experimentation, application, and research trends we will be seeing towards it. Let me have my presentation open.
Ma'am, are you able to share? Dr.
Hello.
Sudeshna? Yes,
Yes.
ma'am.
Hello. Is
Yes,
it
ma'am.
visible?
No, ma'am.
Not yet. Let me
Now,
share my
now
screen
it is
itself.
visible. Your screen. Now it is visible. Yes, it is
Okay.
visible.
Thank you. Yeah. So let's have the introduction to big data analytics, basically what it is all about. Over the years, we know we have the data, we have the information, but without data, there is no information. But information, we can have the big data, the analytics on the part of the raw data. It will be on the objectives of this particular session or the unit is what is big data, the 3 B's of big data, the importance of the big data, the risk, the analysis, the structure, the adoption structure, various barriers, and of course the research trends on the big data aspects. So what is big data? Generally, big data is a general term used to describe the voluminous amount of unstructured and semi-structured data. These unstructured data are scattered here and there. It is the need of the hour to produce them in the format which is useful and which will be close to the decision-making format, or you can say the MIS format that is relevant for the to take the decision fraud. The big data term is often used when speaking about petabytes and exabytes of data. So it turns about the speaking on the part of terabytes and exabytes of data rather than just a gigabytes. The famous quote goes by Ms. Guinea, the CEO. She once told that the customer segmentation and has forced the marketeer to understand each customer as an individual within 18 months. So focus is on the customer centric market to understand the need and the requirement of the customer and the risk associated with it. In a very short span of time, this focus will be very much relevant for market segmentation. Without big data analytics, companies are generally blind and deaf, wandering out onto the web like a frenzied deer. It is said by Sir Geoffrey Moore, American management consultant and author. So it is generally accepted that in the form of unstructured data, structured data, or most of it located in text file accounts for at least 80% of the organizational data. Now let's see what are the three V's that we are talking about for the big data. First is the volume. The volume indicates the amount of data for analysis. The characteristic that is most associated with big data, volume, refers to the mass quantity of data. So volume are unprecedented rate increasing, and big data has the capacity, the capability to handle such huge explosive data on a day-to-day basis. The variety is about managing the complexity of multiple type of data, which can be structured, which can be semi-structured and unstructured data. Clustering, classification, and then regression are the point where the big data encroaches and help us towards finalizing the data mining. So that partly related with the variety on the big data part as well. Organization need to integrate and analyze data from a complex array of both traditional and non-traditional information sources. Explosion of sensors, smart devices, social collaboration technology, which generates data in countless forms like text, web data, tweets, sensor data, audio, video, and more. Are the some of the examples that variety explodes towards. Now let us see what is velocity. The velocity stands for data in motion, this is analyzed per second in a continuous acceleration. Velocity impacts latency, the long visible. Without data, we don't have any information. Impossible for traditional system to capture, store, and analyze. So velocity, the speed is the acceleration in the form of huge enability on decision making for the management milestone through which can be classified: volume, variety, and velocity. What are the need for big data? Big data can unlock significant value by making information transparent. And organizations create and store more transaction data in digital form. So big data allows ever narrower segmentation of customers and therefore much more precisely making it a valuable insights that would otherwise remain hidden. So big data is not just a buzzword, it is also an insight towards business intelligence and the data which is so far hidden and kept under the carpet. Big data can be used to develop the next gen of products and services with that frenzy market building capacity. Now let's come to the benefits and barriers of big data analytics. Of course, every coin has two faces. So benefits of big data analytics are anything involving benefit from big data analytics. So customer who are relevant to you, who are specifically useful to you, you have to segregate, and the customer which are not your organic customers has to be segregated with the help of the big data analytics itself. Business intelligence in general can benefit from the analytical tool, decision-making tool, the regression tool that they are continuously in line making the mankind into the decision-making capabilities. Specific analytical application are likely beneficiaries of big data analytics. Now let's come to the barrier. As the benefit goes, there are the barriers. The inadequate staffing, the inadequate skills are leading to the main barrier towards the big data analytics, because the way the data is exploding, the huge terabyte, exabyte, and zettabytes of data cannot be handled with a small populatory index of the HR resources. To make it in the leap and bound, the staffing and the skilled staffing specifically need to be engaged in the company scenario. A lack of business support can hinder a big data analytical program as well. Problems with database software can be barriers to big data analytics. Now let's see the intrinsic property of data, how it grows. 90% of the world's data was created in the last 2 years. So 1 in 2 business leader don't have access to data they need. 80% of the world's data today is unstructured, and 83% of CIOs cited BI and analytic as part of the visionary plan. This is the second phase of big data analytics, which is also alarming. And towards then we goes to the 20% of available data that can be processed by traditional system, and 5.4 times more likely that top performers use business analytics. This is just an intrinsic property of data, how it grows and where the big data comes into the picture. After all, a growing, interconnected and instrumental world. You can see here how the social media, the 500 plus million users posting 55 million tweets every day, 1 plus billion active users spending 700 million minutes per month. So every awareness, every uh, useful data or non-useful data is, after all, the trend that is connected to the instrumental world through big data. 30 billion RFID tags starting from 2005, then 4.6 billion camera phones worldwide, 100 of million of GPS enabled devices sold annually. These are the rough estimate actually how the data's explosion on the growing interconnected world grows and where we need to see ourselves in the near future. The fourth V is attached for understanding the larger concept, the veracity and the uh, versatility of the data, where it can take over the population of data sources. 1 in 3 business leaders don't trust the information they use to make decisions. The fourth V is also added with the added parameters already in the third V, 3 Vs. These are the some of the challenges that big data through the structured, unstructured, and semi-structured data have achieved. The archives, the docs, the business apps, media, social networks, public web, data storages, machine log data, and sensor data are prevalent and the challenging factors. What is the basic difference between traditional analytics, which we popularly know as BI, that is business intelligence, and big data analytics? Traditional analytics basically focus on descriptive analytics and diagnostic analytics. What your product are about, how to centralize your market on description, on the product-based marketing, that is the proper term, descriptive analytics. This is statistics also, you know. So these are mostly on the center that has focus on the diagnosis, that has focus on the predictions. So this has a modern aspect on big data analytics as a predictive analytics and data sciences, which not only segment, collect, clean, but also control the historical data to better understanding changes that can be imbibed and incurred throughout the business. Using a range of historic data and benchmarking, decision making can be outbound and can be holistic. Now, what are the data set that has been used by BI is very limited data set. It has to be cleansed, it has to be forming a simple model, and it support what happened, and that is causation, that what causes the data, which have the supporting factor here. While with big data analytics, we have large scale data set, more type of data. Basically, we are making the data more valuable. Slowly, the more the data is tortured, the more it will come to a different decision making prediction near the future for the analysts. Large scale data set, more type of data, complex data model is one which is way beyond the traditional BI. The correlation is more effectively used here with new insights on more accurate answer. So customer-centric model on decision-making capability is what big data analytics has to offer over traditional analytics. What is the solution architecture on this problem or the challenges that has been faced by today's scenario on various aspects of business and social networking tools. So technologies that we have are Amazon Redshift, Amazon SQS, Amazon S3, Elastic Beanstalk, Jaspersoft BI Professionals, and Python. Now let's see what are the different big data careers that are growing in the market that are applicable for the scholars and also for the newbies in the professional world. Though there is a general big data professional term and commonly known as big data career, but one can explore many capability of interest. So these big data careers can be as follows. First is the big data engineers, who are professionals responsible for building the design made by solution architects. It is one of the well-known and demanding big data careers. It is the most common role in the big data world. Big data engineer is the one who develops, tests, maintains, manages big data solution in the organization and multidimensional. Now we have data scientists, one of the most sought after among available big data careers. The data scientists are the people who use the analytical and technical skills for the extraction of the insight from the big data. They turn the structured and unstructured data into meaningful insights. Some commoditization of hardware enabling new analytics, low cost compute platform with Hadoop architecture mainly make the various distributed file system available and cluster of affordable machine running on distributed data processing with map reduced technology is prevalent. Hardware failure is expected and managed. Hardware appliances are also used with up and running clustering in new hours. Then we have cloud up and running with a new cluster in minutes. So these are some of the commoditization of hardware, which analytics include. 5 keys of big data uses: the big data exploration, which has to find, which has to visualize, understand all big data to improve decision-making skills. The second, you can say KPI, key performance indicators, are the enhanced 360-degree view of the customer, which extend existing customer views by incorporating additional internal and external data sources, security or extensions. We have also the capabilities on the additional internal and external data sources on 360-degree view. Security, we have also covered cyber security in real time, lower risk detection of fraud. Then we have the next parameter or the next, you can say the milestone on key use case is operational analysis. Analyze a variety of machine data to improve business result. Then data warehouse augmentation, which integrate big data and data warehouse capability to increase operational efficiency. There are different new ways, more ways on wide ranging analytics and techniques. Spatial analysis tool, where you can find some latest research trends also on finding the spatial analysis on the coverage of big data. Then statistical analysis, we all are using different type of algorithm, the tools that are prevalent for regression and correlation on the analysis of our present data sources. Then text analysis, changing of voice synthesis into text coverage. Neural network and lexical analyzer are the main tools through which text analysis can be done using big data efficient tools. Then temporal analysis, of course, machine learning and AI, artificial intelligence, has a huge donation towards big data. Data should not forget is the prime features through which machine learning algorithm, machine learning, reinforcement learning can be under the supervision of the researcher for such type of requirement, which can use for applied business analytics and help the executives to take better decisions. Audio analysis, we already have seen how The analytics is playing the major role in entertainment industry on audio and music by mixing and tracking the various tracks and bring back the old songs, the oldies, towards the new generation marketeers with the help of big data tools. And we have video analysis and of course image analysis using OpenCV tools, using augment sensor ability tools, and also some of the very relevant tools that can help in the analysis towards wide ranging techniques and of big data. Now let's see the complexity in healthcare. Medical information is double, which is unstructured. So diagnosis, 1 in 5 is possible that are estimated to be inaccurate or incomplete. 81% of physical reports spends hours or less per month on reading medical journals. So 1.5 million errors in the way medications are prescribed, delivered, and taken in the US every year. These are some flaws and complexity that big data into the solution as a problem definition. So to keep up with the state of the art, we have various papers, we have various white papers, the technical papers that are continuously into the stream towards making some better solution on health care and biomedicals. Big data platform and application framework, it has been visualized under 3 stages.
मीटिंग चल रहा है तुम्हारा?
Closing the door. So gather, extract, and explore data using best of breed visualization and discovery. IBM data platform is taking its characteristic on application and development for the next stage, and then system management. Cost efficiency analysis in the stream of petabytes of structured and unstructured information. Here comes the various accelerators like Hadoop system, contextually discovery, metadata tools, stream computing, and data warehouse tool as well. At the end of the architecture, we have governing data quality and manage information lifecycle. So information integration and governance is the last parameter of these architectures. At the output, we can have a speed, time to value with analytic and application accelerators, the analyzing on streaming data and large data bursts for real-time insights, indexed and federated discovery for contextually collaboration insights, deep insights with advanced in-database analytics and operational analytics. So at the end, the output is to get the deep insights on the advanced tools of database analytics that is moving toward cloud, mobile, and security. This is a complete infrastructure and architectural model of big data analytics on the stream of analytics and decision making. Some of the example on big data platform in practices, how BI reporting and predictive analytics has taken a toll on analytics and report zoning. The warehouse zone comes in. So ETL, MDM, and data governance is all about how your process on big data goes. So these tools are very important. These ETL tools are important in the perspective of solutions and pipelines for automated industry on the perspective of big data. Extraction, transformation, and load. These are some of the manifesto on which big data works. Understand and navigate federated big data sources, federated discovery navigation, the consumables through structured and controlled data, and the output we get the data warehousing, manage streaming data, stream computing. Then the manifesto can be analyze unstructured data, and we have text analyze engine, integrate and govern all data sources and integrity towards data quality, security, and ILM, MDM are the next. These are some of the use cases for big data platform. The problem manage the several petabytes of data, which is growing at 40 to 100% per year under increasing pressure to prevent fraud and complaints to regulation. These are the problem definition that you can think on your research. Those in research scholar using some financial data analytics, they can take use of such type of problem where growing need of the customer and the frauds and complaints on the regulation part, they can take on the big data analytics, how they can help to fraud detection through risk management and a 360-degree view of the customers. They can provide and put forth on this particular problem area as a solutions. Then we have telecommunication use cases for big data platform. The problem is legacy system is used to gain insight from internally generated data, facing issues of high storage cost, long data loading time, and long administration processes. So how big data come into help? By CDR processing, by churn processing, by geo mapping and marketing, or network monitoring. These are some of the spaces where telecommunication comes into being. Then for a transportation system, the traffic congestion, accidents, the result of increasing urbanization and concrete cities that are building through population growth, reducing the efficiency of transportation infrastructure and increasing travel time towards and a fuel consumption on a metros. So how the big data analytics can help by putting a real-time analysis to weather and traffic congestion data streams to identify traffic patterns, reducing transportation cost. Healthcare and life sciences, we already discussed how huge data can be analyzed and what are the different problems where big data can encroach and provide the daily solution on the parameters of some monitoring devices. So believe me, as told by the researcher, by the scientists, that slowly 100% doctors and medical services are being taken over by the big data analytics. Now, physical doctors will be rare in near futures, and everything will be taken over by the analytical tool, by the predictive analytic tool, by the various CDR tools that are being prevalent for ETL processes. How big data analytics can help by epidemic early warning and intensive care unit and remote monitoring for healthcare and life sciences. I think with this, you can take up this small quiz. Big data generally refers to, yes, please, you can unmute yourself and answer. Voluminous structured data, voluminous unstructured data, voluminous semi-structured data, both B and C. What will be the